Hi, today we'll take a look at an interview question from DoorDash. This is a medium-level question, testing your ability to deal with dates and knowledge of case when statements. In this video, I'm going to show you how I approach the question. I'll break it down step by step so that you can familiarize yourself with the thought process to successfully tackle your SQL interview. If you haven't already, check out our Strata Scratch channel, which is dedicated to helping you ace that data science interview. And better yet, hit the subscribe button so you don't miss any new videos. So here's our question from DoorDash. Imagine you're a data analyst at DoorDash, and management wants to know for every month what percentage of their orders are extremely late deliveries. And extremely late here is defined by the difference between the actual delivery time and predicted delivery time. If that's over 20 minutes, the delivery is considered extremely late. Now, this is a very interesting question as it's an analysis you would most likely encounter on the job. If you have researched the company beforehand, which I would highly recommend, this is the time to demonstrate your understanding of the business. Think about why such analysis would be needed for this type of business. What insights are they trying to uncover, and what decisions might this analysis impact? This provides more context to the problem you're trying to solve and helps you frame your analysis better. For this question, it makes sense that DoorDash wants to investigate their delivery times. On-time delivery is crucial to ensuring customer satisfaction, especially in the food industry where time can directly impact food quality and safety. So that's our rationale here, and let's think about what information we're trying to draw from this. Intuitively, we could monitor the absolute number of extremely late deliveries month on month. However, we can't look at this number alone. The total number of deliveries per month changes and fluctuates based on season, holidays, and due to general growth of the company. So a better metric to track is the percentage of total orders that are extremely late. So that's our general analysis of the problem statement. Now that you've articulated that to the interviewer, let's start formulating the solution. I highly recommend using a framework because this will help you structure your thoughts and communicate them in a way that the interviewer can follow. This is important because oftentimes it's not only your coding skills that are being tested, but also your communication skills. These are the steps included in our recommended framework for answering data science questions. Let's explore and understand the dataset. We're provided with a delivery orders table showing the delivery ID, the time when the order was placed, when it was predicted to be delivered, when it was actually delivered, the rating provided to that delivery, and the IDs of the dasher, the restaurant, and the consumer. And here is a preview of the table on the right. Now, it's easy to imagine how this information was captured. If you think about the process, once an order is placed, it's assigned a unique delivery ID, and the relevant details about the order like the customer, the restaurant, the date and time of the order are then logged. The delivery time, or I guess expected time of arrival for delivery, is computed, and the order is then assigned to a dasher whose ID is also included in the table. And once the order is delivered, the exact time is logged and the customer provides their feedback through a rating. And that's probably what happens to most of the orders. But what if the order is cancelled? Or what if the delivery is in transit, as in the order was placed but not yet delivered? You can ask these clarifying questions to your interviewer, but for now, let's assume that the dataset contains only fulfilled orders. Now, let's unpack what's required to get to the target output table. The question asks us to show the proportion of extremely late orders for each month. So in particular, our output should look something like this. So here we have to extract the month and year information from the order place time column. And looking at the percentage of extremely late orders, we would need to calculate the total number of late orders and the total number of orders for every month. Getting to the number of total orders should be easy because we only need to count the number of unique delivery IDs. Now the tricky part is getting the total number of extremely late orders per month, since that's not directly available. As we gathered earlier, in order to determine whether an order is extremely late or not, we will have to compare the columns predicted delivery time and actual delivery time. Remember, the definition was If the actual delivery time exceeds the predicted delivery time by more than 20 minutes, then this order is extremely late. Now, to determine this, we'll create another column for extremely late orders using the case when statement. And our high-level approach looks something like this. Now, one thing that's helpful at this stage is to check in with your interviewer on this high-level approach. See what they think and get some feedback early on. If that's all good, we can now code the approach. So let's first get the two core ingredients of this solution, which is to identify the late deliveries and also extract the month-year information in the format required. Let's start with extracting month and year from the order place time column. To retrieve the specific information from a date time variable, which is what this column is, there are several options available to us. First, we have the extract clause. Extract allows us to extract a portion of the date time values like month, year, day of the week, minute, and so on. It follows this syntax, which is actually very similar to another function called datePart, except that the syntax is this, where it takes the field as a string and takes a second argument, the column. However, we won't be focusing on these functions since they do not directly get us to the format we need, which is this 4-digit year and 2-digit month format. Instead, we'll use the toChar function as it allows us to reformat the datetime variable in a more customized way, essentially converting it into a string according to the format we provide. So we can rewrite the order place time column in the year-month format with this function. Moving on to the second part that we need, which is identifying extremely late deliveries at the row level. Now, the case when statement will allow us to capture the if then else logic in SQL. So we can use something like this. But subtracting these two datetime variables will give us an output in seconds, but we want the comparison in minutes. So we can either do a transformation manually, such as this, essentially dividing it by a factor of 60, or use some of the functions we talked about earlier with extract or datePart. So revising our earlier code, we now have this, which will give us a 1 if the delivery is extremely late and 0 otherwise. Now, the only information or columns we need for the next steps are the following. 1. Order place time in the year and month format, which we have already derived. 2. The delivery ID, which is readily available and provided to us. And 3. A column indicating an extremely late delivery, which we have just created in our last step. So for each year month, we calculate the sum of all extremely late deliveries, as well as the total deliveries. Great! Let's move on to the last step of creating a final table, which is to firstly calculate the percentage of extremely late orders for every year month. We will divide the total late deliveries by the total orders and multiply that by 100 to get us the percentage. Keep in mind that in getting the proportion of extremely late orders per month, we're expecting a number between 0 and 1, in other words, a float. However, if you look at what we have currently, both of the columns, total extremely late and total orders, are integers, so dividing the two defaults to integer division, which will also return an integer, and that's not the precision level we want. In this case, simply dividing the two columns will result in zeros. So to get the results as a float type, at least one of the columns has to also be a float. So let's convert this by doing this. And here's our full solution. Congratulations! If you have more time left at the end of the interview, think about how else you can improve the solution. For example, we can try to rewrite our code to make it easier to follow, and a handy trick is to use CTEs, which stands for Common Table Expressions. Using CTEs is especially helpful where we've done some column transformations or where we've written more complex code, making our full solution harder to understand and debug in case of errors. In this case, recall we created a temporary table before aggregating our final results, which can actually be stored as a CTE by this syntax. Now let's try to run this. So the output of our query is as follows. The results call for attention as DoorDash had some months with a high proportion of extremely late deliveries. As we can see here, the worst performance was in January 2022 with around 36% of the orders being extremely late. Likewise, November 2021 also had troubling delivery performance at 31%. With this, management would want to investigate the root cause so that extremely late deliveries are kept to a minimum, as we mentioned before. Otherwise, the long wait might be shunning away DoorDash's valuable customers. If you've enjoyed this and found it helpful, check out our other videos as we show you how to tackle data science technical interviews of varying difficulty levels. Click on the link below and hit the subscribe button.